Both the genetic sampling and the physical catches aligned perfectly. They both confirmed that the farm environments completely lacked the complex epifauna and the fish communities you would normally find in wild benthic reefs.
Wow.
Yeah, the biological mass just isn't there. Biologically speaking, the farm environments looked almost identical to the empty pelagic controls.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production. Inspired by the 2025 article titled, Combining Environmental DNA and Traditional Sampling to Assess the Role of Kelp Aquaculture as an Artificial Habitat in Norway by Andrews Adam Yon et al.
Let's rethink artificial marine habitats for a second. Because there is this lingering assumption that, any infrastructure we put in the water just immediately attracts this complex, diverse ecosystem.
Or the whole artificial reef concept.
Exactly. But when you actually examine commercial-scale macroalgae production, that assumption just completely falls apart. So today we're jumping into a 2025 paper by Andrews, Christie, Preble, and their colleagues, which is titled Combining Environmental DNA and Traditional Sampling to Assess the Role of Kelp Aquaculture as an Artificial Habitat in Norway.
It is a really fascinating piece of work.
It really is. And our focus for this deep dive is to unpack a pretty critical operational question for you. Do suspended kelp arrays actually mimic wild benthic zones? Or does highly efficient commercial production just, naturally isolate itself from local food webs?
Which is a massive question for site planners and production managers in our industry. Andrews and the team, they really wanted to map out the exact ecological footprint of these operations.
Right.
Feed formulation software is stuck in the past. Most tools haven't evolved beyond basic least cost optimization. A Diet Forge changes that. It's an AI-powered platform with nonlinear ingredient modeling for enzymes and additives, cost per gain and maximum profit optimization, and real-time collaboration like Google Docs for nutrition. Every recommendation is grounded in world-class research, built for modern nutritionists who need more than legacy desktop software can deliver. Work seamlessly with your team and optimize the way modern operations demand. Try dietforge.ai free today. Feed formulation, finally modernized.
So they compared commercial Norwegian farm sites directly against wild kelp forests and also against open water pelagic controls.
Just to get a proper baseline.
Exactly. And rather than relying on just one metric, they paired traditional physical traps and netting with environmental DNA water sampling.
Okay, wait, let me stop you right there. Because these commercial sites, they're almost always placed in highly exposed, high-energy hydrodynamic zones, right? To maximize nutrient flow across the biomass.
Right, you need that water movement.
So shouldn't that water velocity just, flush all the environmental DNA right out of the sampling area?
Yeah.
Are we sure we aren't just looking at a false negative for biodiversity just because the genetic markers are constantly washing away?
No, that is a very valid structural concern. High flow rates absolutely dilute genetic signals in the water column.
Yeah.
And, if they had only used environmental DNA, the results would be highly suspect. But that is exactly why running the physical gill netting and the physical traps concurrently was so important.
Ah, I see. So the physical catch verified the genetic data.
Spot on. Both the genetic sampling and the physical catches aligned perfectly. They both confirmed that the farm environments completely lacked the complex epifauna and the fish communities you would normally find in wild benthic reefs.
Wow.
Yeah, the biological mass just isn't there. Biologically speaking, the farm environments looked almost identical to the empty pelagic controls.
Okay, so the data is incredibly solid. The farms really are just that devoid of local fish populations. But that isn't some random environmental fluke, right? That is a deliberate, engineered result of how we structure our production cycles.
Oh, absolutely. It all comes down to the harvest schedule. Commercial producers are typically pulling this crop out of the water early, usually in May.
Right, before the water gets too warm.
Exactly. By harvesting before water temperatures really spike, they are deliberately preventing biofouling. You want pristine biomass for processing.
Of course. Crop integrity is everything.
Right. So avoiding a climax community of marine microorganisms and invertebrates is how you guarantee that quality.
Let's break down the biological mechanism there for a second. If you pull the lines before those invertebrates can fully establish, you completely cut off the bottom of the food web.
Yep.
And, well, no invertebrates means no prey for smaller fish, which means larger predatory fish have absolutely zero reason to aggregate around the suspended lines.
That is exactly the mechanism. And for commercial aquaculture, I mean, this is a massive operational win.
Because it keeps things clean.
Yes, you are maximizing your yield and protecting the integrity of the crop, all without inadvertently building this unmanaged artificial reef that complicates the local ecology.
Right. It proves we can scale up our production footprint while keeping the operations strictly focused on the target yield.
Precisely. It is highly efficient.
But looking at the data, there's one really fascinating outlier. While most fish completely ignore the infrastructure, juvenile lumpfish, Cyclopterus lumpus, they were actively using the farm sites.
Yeah, they were definitely showing up in the data.
But how are they surviving there if the prey base is so low?
Well, because they aren't there to forage. Cyclopterus lumpus is a shallow benthic-dwelling species. They rely heavily on physical structures to hide from predators and to manage their energy output in those strong ocean currents.
Oh, interesting.
Yeah, so to a juvenile lumpfish, a dense suspended kelp line basically functions perfectly as a false ocean floor.
Right. They are utilizing the physical architecture of the farm for shelter, just completely independent of the food web dynamics.
Exactly. It's structural, not nutritional.
Which, I mean, that opens up an incredibly interesting operational window for integrated pest management.
Most companies know AI can help, but the hard part is getting it deployed inside the business. Elevate Agents builds and launches custom AI agents that handle repetitive workflows, reduce manual overhead, and help teams move faster without adding headcount. From identifying the right use cases to deploying agents that actually work in your operations, Elevate turns AI from an idea into execution. Build smarter systems with Elevate Agents. Visit elevateagents.ai.
We all know how valuable lumpfish are as cleaner fish in salmonid operations.
Oh, hugely valuable.
So if they are naturally aggregating in these suspended macroalgae systems, producers could start looking at kelp farms as, well, dual-purpose infrastructure.
You hit the nail on the head. You keep the production lines clean of biofouling to maintain premium macroalgae quality, but you simultaneously provide a functional nursery habitat for a high-value operational asset.
It's brilliant.
It really takes the whole concept of limiting ecological disruption and flips it into a targeted, managed advantage for adjacent finfish sites.
Which leaves you with a really interesting operational concept to map out. Imagine spatially designing future integrated multi-trophic aquaculture sites so that your macroalgae arrays are strategically positioned specifically to aggregate lumpfish.
Oh, that would be incredible.
Right. Could we perfectly time the seaweed harvest to align with the exact moment those cleaner fish need to be transferred into the neighboring salmon pens?
Man, synchronizing the harvest cycle with cleaner fish deployment like that, it would take production efficiency to an entirely new level.
You really would.
Yeah.
We will leave you to run the numbers on that one.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.